A quadrilateral is a polygon that has four sides. Unless otherwise stated, the term quadrilateral refers to a figure such as ABCD in Figure 4.1a, in which the line segment sides lie within a single plane. When the sides of the quadrilateral are not coplanar, as with MNPQ in Figure 4.1b, the quadrilateral is said to be skew. Thus, MNPQ is a skew quadrilateral. We generally consider quadrilaterals whose sides are coplanar. Definition: a parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. Because the symbol for parallelogram is parallelogram, the quadrilateral in Figure 4.2 is parallelogram RSTV. The set is capital P equal to the set of parallelograms, is a subset of Q equals the set of quadrilaterals. Theorem 4.1.1. A diagonal of a parallelogram separates it into two congruent triangles. Given: parallelogram ABCD with diagonal line segment AC. See Figure 4.3. Prove: triangle ACD is congruent to triangle CAB. Proof. Statements. Reasons. Statement 1. Parallelogram ABCD. Reason number 1. Given. Statement 2. Line segment AB parallel to line segment CD. Reason number 2. The opposite sides of a parallelogram are parallel. Definition. Statement number 3. Angle 1 is congruent to angle 2. Reason number 3. If two parallel lines are cut by a transversal, the alternate interior angles are congruent. Statement number 4. Line segment AD is parallel to line segment BC. Reason number 4, same reason as 2. Statement number 5. Angle 3 is congruent to angle 4. Reason number 5, same as reason number 3. Statement number 6. Segment AC is congruent to segment AC. Reason number 6, identity. Statement number 7. Triangle ACD is congruent to triangle CAB. Reason number 7, angle side angle. Corollary 4.1.2. The opposite angles of a parallelogram are congruent. Corollary 4.1.3. The opposite sides of a parallelogram are congruent. Corollary 4.1.4. The diagonals of a parallelogram bisect each other. Recall the theorem: if two parallel lines are cut by a transversal, then the interior angles on the same side of the transversal are supplementary. A corollary of that theorem is stated next. Corollary 4.1.5. Two consecutive angles of a parallelogram are supplementary. Theorem 4.1.6. Two parallel lines are everywhere equidistant. Definition. An altitude of a parallelogram is a line segment from one vertex that is perpendicular to a non-adjacent side, or to an extension of that side. For parallelogram RSTV, segment RW and segment SX are altitudes to side segment VT, or to side segment RS, as shown in Figure 4.5a. With respect to side segment RS, sometimes called base segment RS, the length RW or length SX is the height of RSTV. Similarly, in Figure 4.5b, segment TY and segment SZ are altitudes to side RV, or to side ST. Also, the length TY, or ZS, is called the height of parallelogram RSTV with respect to side segment ST, or segment RV. Next, we consider an inequality relationship for the parallelogram. To develop this relationship, we need to investigate an inequality involving two triangles. In triangle ABC and triangle DEF of Figure 4.6, segment AB is congruent to segment DE, and segment BC is congruent to segment EF. If the measure of angle B is greater than the measure of angle E, then the length of AC is greater than the length DF. Lemma 4.1.7. If two sides of one triangle are congruent to two sides of a second triangle, and the included angle of the first triangle is greater than the included angle of the second, then the length of the side opposite the included angle of the first triangle is greater than the length of the side opposite the included angle of the second. Now we can compare the lengths of the diagonals of a parallelogram. For a parallelogram having no right angles, two consecutive angles are unequal but supplementary. Thus, one angle of the parallelogram will be acute and the consecutive angle will be obtuse. In figure 4.7a, parallelogram ABCD has acute angle A and obtuse angle D. Note that the lengths of the two sides of the triangles that include angle A and angle D are congruent. In figure 4.7b, diagonal segment AC lies opposite the obtuse angle ADC in triangle ACD, and diagonal BD lies opposite the acute angle DAB in triangle ABD. In figures 4.7c and d, we have taken triangle ACD and triangle ABD from parallelogram ABCD of figure 4.7b. Note that segment AC, opposite obtuse angle D, is longer than segment DB, opposite acute angle A. On the basis of Lemma 4.1.7 and the preceding discussion, we have the following theorem. Theorem 4.1.8. In a parallelogram with unequal pairs of consecutive angles, the longer diagonal lies opposite the obtuse angle.